In this last section of this unit, we are going to be focusing more on symmetry today. So in the activity that we just did, so hopefully that was, yesterday or whatever the last day of class was for you guys. Symmetry, that activity that we talked about yesterday where you guys had to use your patty paper to discover if shapes had line symmetry at all or rotational symmetry. We're going to talk more specifically about those ideas that we kind of started to see yesterday. So you saw on that activity how sometimes if you have a shape and you put it on your patty paper and you were able to fold it, that everything matched up, or sometimes it didn't match up. It didn't have any line symmetry. And sometimes we even saw that if we pinned our shape in the middle, so we kind of just stuck our pencil down and we turned it around, that sometimes it lined up the exact same. I want to talk a little bit more about symmetry and kind of more formally, what is the definition of symmetry? And then we're going to get into some more practice of identifying symmetry and also being able to take shapes and be able to create symmetry. So be able to take something that maybe we need to just add some detail to in order to make it have some type of line or rotational symmetry. Okay, so in order for an object to have symmetry, what that means to us is that it carries onto itself. So that means yesterday or whenever it was you guys did your symmetry activity, when you folded your patty paper, everything kind of matched up real nice and neat. So everything, all the corners had a nice matching corner, all the sides had a nice matching side. So everything was nice and clean when it had symmetry. So it's kind of imagine if you divide a shape down the middle or diagonally or across its long side or whatever, and you fold it over that line and everything matches up, that means it's going to have symmetry. Okay? There are two types of symmetry. There's that reflection symmetry. Another word for that would be line symmetry. Okay, and that's probably what I'm going to use more often than saying reflection symmetry. You'll hear me say line symmetry because that's what's happening is we're drawing a line in the shape and it's being reflected over both sides. And then the other type of symmetry would be rotation. So can you take your shape and turn it around a point and have it look the same? Okay. All right, so the definition of line symmetry, okay, so kind of getting a little bit more into the details here of that reflection symmetry. This means that you draw a line and the two halves match. So you can draw any line. So you could, when you're trying to find symmetry, you can draw lots of lines to see if any of them would work. Okay, so you can draw them vertically, horizontally, diagonally, whatever. You're drawing all these different types of lines and you're trying to find one that would maybe cut your shape in half and have it match up on both sides. Okay, so let's look at some examples and figure out if we think that they have line symmetry or not. Let's do this first one together. The heart. Okay, do we think the heart has line symmetry? Maybe you think yes, maybe you think no. Okay, if you start trying to draw lines, if you draw a line like this, that's obviously not going to work because the top doesn't look the same as the bottom. So that doesn't work. So maybe you try a bunch of them, or maybe a lot of you are thinking, I see it. It's right there down the middle. Like if I draw my line right there. If that line gets drawn down, so imagine if you had this heart in your hands and you fold it over, the left-hand side should match the right-hand side. In fact, probably when you guys were like in grade school and you had to cut out hearts for something, you were probably told to do that. You were probably told to fold a piece of paper in half, draw the one side of the heart, and then cut it out, and then boom, you had a full heart, right? So hopefully maybe remembering that lets you see that you do have line symmetry. Now there is only one line of symmetry on that shape. There isn't more than one. Okay, let's do number 2 together as well. Be careful on number 2 that you don't double count. So I'm just going to write a little note here. Don't double count. That means that if you use the line, so like this one that goes right up and down through the center of that flower, that counts as one line. So if you go all the way to the top to the bottom, When you get back down to the bottom, you don't want to count it again because then you just went back over that same line. So that's 1. Okay? If we go through all the petals, there's 2, 3, and there are a couple more. These ones you can kind of see that they're in between those petals. So here's 4, 5, and 6. So this one has 6 lines of symmetry. Again, a common mistake that I would see there is someone would put down 12 because they start at the top of the flower and they just count all the petals and all the spaces in between all the way around and they get 12. Okay, you don't want to do that though because the line goes all the way through the shape. All right, so here's what I want you guys to do. Take a minute or two here and work on 3 through 8. Be careful with some of those. Be extra diligent here. And when you're ready, resume watching this video. Okay, so go ahead and pause it here. Take your minute, 2 minutes, whatever you think you need in order to do 3 through 8. And then when you're ready to see the answers, go ahead and keep watching. All right, so you want to be careful on some of these. A couple of them are a little bit tricky. Okay, and again, remember I said when you're trying to find lines of symmetry, you can draw any line you want. So it can go in any direction. All right, so for 3, the line that you're going to use goes across like this. So that has 1 line symmetry. 4 has 0 lines of symmetry. There is no way to cut that triangle. Maybe if you struggle with like trying to find the lines of symmetry, use your patty paper to help you. So lay your patty paper down on that shape, draw it, and then start folding it like you did on that activity. If you can't find one that works, then you know it's got to be a no. Okay? Number 5. Be really careful with this one. A lot of times I see students say 3 here, but if you draw a line through this shape, like there, let's say, remember that the sides have to match. You know, some of you, this would especially be helpful on patty paper. It gets a little messy because there's a lot of lines there. But if you try to fold it over, all those lines do not match. They don't lay nicely with each other. So this one is actually a no as well. So it has no lines of symmetry. Okay, number 6, you should be able to find 3 of them. Number 7 only has 1, goes across the B like that. And number 8, very similar to number 5, it's got a lot of detail because it's not working. Like if I go down, up and down here, or left to right, there's not going to be any line symmetry on that one either. All right, hopefully you didn't skip all the way down here yet because these ones look a little bit different. They want us to shade these shapes so that they have a specified amount of line symmetry. Okay, so for example, number 9 wants us to shade it so that you only have 1 line of symmetry in the shape. So they don't want 2 lines, they don't want 3 or 4 lines, they only want you to have 1. So you have to be a little bit careful about where you shade on the shape. Okay, let me tell you what I mean. Sometimes students will want to do this. Okay, because that looks symmetrical. But I could cut the shape here and have it look the same on both sides. I could also cut the shape here and have it look the same on both sides. That's already over 1. So that's not what they're wanting us to do. So we cannot do that. Okay? So instead, we need to think about how do we shade this so that it only has 1 line that can go through it. If you shade the top and the bottom of those red squares, like that, all the way over there on the right side, the only line of symmetry that you would have then would be this one. So that would be the way to do that, okay? Now, 10 is kind of back to what I was talking about earlier. This one does want 2 lines of symmetry. So this one would be okay if we did shade in this one here, because then you would have this line symmetry and you'd have this line symmetry. It doesn't work though if you do it diagonally, because then those colored squares aren't going to quite match to each other, okay? You guys take a minute here and do 11 and 12. Shade them. They want them both to be shaded so that they have exactly 4 lines of symmetry. Okay, number 11, shaded so it has 4 lines of symmetry. So we know that if we do this, it's got 2. So we need to figure out a way to get 2 more. If you shade the top middle and the bottom middle, then you should be able to go vertically, horizontally, and diagonally. You should be able to do all of those. So there would be your 4. For number 12, I would shade in all the corners so that once again you can go up, down, left, right, and then do your 2 diagonals. All right, let's turn our page over here. So the top is asking, what are the characteristics of a polygon that produces the maximum amount of symmetry for its number of sides? So before we move on from line symmetry, we saw this back on this page on number 6 here. So this one is a triangle. Okay, triangles have 3 sides. We also are given that those 3 angles, they're all looking like they're the same and they're all marked so that they're congruent to each other. So those 3, or that type of triangle that has 3 congruent sides, 3 congruent angles is going to have a line symmetry of 3. So any shape, any polygon that has all the same side length and all the angles on the inside are the same, it's going to have however many sides that shape has number of line symmetry. So if all sides are the same size, then the number of sides that the shape has is going to equal the number of line symmetry that it has and order, which we're going to get into next here. A word for these types of polygons would be called regular polygons. So if a shape is ever considered regular, or if they tell you that a shape is regular, they're telling you then that all the sides are going to be the same length. Okay, so now let's get into rotational symmetry. Rotational symmetry is a little bit different because we're not drawing lines through it. We're thinking about if I have like a point that I'm using as like my rotation, my center of rotation, and I turn my shape around it and it looks the same at some point, that's considered rotational symmetry. And the number of times that I can make a shape do that as I'm turning it around is going to be its order. So order of rotation symmetry is the number of positions in which the object looks exactly the same. It's called the order of symmetry. When you're determining the order, the last rotation returns the object to its original position. Order of 1 implies that there's no true rotational symmetry since a full 360-degree rotation was needed. So if you can't find any other positions for that shape to be turned in and have it look the same, then you have to say it has an order of 1 because it had to go all the way back around in a complete circle before it got back to its original position. Okay, so some of these, when you're dealing with them, might be easiest if you trace them on patty paper and then be able to take them and be able to turn the patty paper on top of your note packet here to see if you can get any of them to look the same. Okay. For example, if I'm going to skip to number 2. If I trace over 2 here, so I've got my S. And I pick that up and I start turning it, so a lot of times we take it and we try to go either clockwise or counterclockwise, whichever direction you want to go here. And we just try to see if there's any point in time that they're going to line up and look the same. So right here's 1. And then when I get back, there's 2. So you count its landing place as 1 as well. So this one had 2. So down below, I'm going to say that my order is 2. Now to find the angle, because there's 360 degrees to go all the way back to its original position, we're going to take that 360 divided by the order. So we're going to take 360 divided by 2 to get our angle, which is going to be 180. Okay, let's do one more together. I'm going to come over here and do number 4. So I'm going to trace over this shape. I'm going to pick it up and I'm going to start rotating it. So right here's where I start. So once I get my blue dot back up to the top, then I know I'm done. Now, this is off a little bit, but there's 1. There would be 2. Again, it's not quite lined up right because my center of rotation's off. And then we're back up at the beginning, there's 3. So this one should have an order of 3. Again, to find the angle, you take 360 divided by your order, 3. And so this one would be 120. Okay, so I want you guys to take a second here, and I want you to finish 1, 3, and then 5 through 8. So take a couple minutes and find the order. So you might need to use your pad paper to trace, and then turn your pad paper around to see if they match up. So you might need to pause your video here so you can take as much time as you need to do these, because these might take a little bit longer. And then when you're ready to see the answers for them, go ahead and continue watching. Okay, number 1, the order should have been 3, so the angle should have been 120. Number 3, the order was also 3, so your angle was 120 again. For number 5, your order should have been 8, so your angle is 45 degrees. 6, your order should have been 4, so the angle is 90. 7, your order should have been 5, so the angle is 72. And 8, your order should have been 2, so your angle is 180. All right, these last ones are very similar to what we saw on the previous page, but this time they want us to shade so that we have an order. Again, I would highly suggest you guys use your pad of paper for these, because if you are told it has to have a certain order, what you can do is shade where they have it shaded here, and then all you have to do is turn your pad of paper around to see where that point should go, where that shading should go, so that you know what the correct answer, the correct shading would be. So what I mean here is, on this one, they only have this corner shaded. I need to turn this around. So you got to almost imagine I take this whole grid and I turn it around, and I want it to land perfectly 2 times. But I got to figure out, like, where do I shade it so that it'll do that? Okay. So this is going to be a little bit difficult for me to show you with my tracing. So that's why I would suggest that you guys use pad paper. I would trace the grid, okay, on your pad paper, and then color in the square that's colored in. Now, because we know down here that the order is 2, and I have an angle of 180, I need to turn my pad paper 180 degrees. So when I do that, you're turning it like all the way. So this square is going to go all the way around to here when you turn it 180 degrees. So what that tells you is that the shading should land in that square over there. So right here is where I should shade. That way, if I go to turn this around, it should land perfectly 2 times. It should go 180 degrees with your pad paper, and then if you rotate your pad paper again one more time, you're back to your original spot, and it should look the same. So that's kind of what I would suggest that you guys do on these ones. So I want you guys, like I said, these are a little bit harder for me to describe and show you up here without just giving away the answer. So what I want you to do is look at the last 3. I want you to trace the grid, shade in the square, and then turn your pad paper the angle that they're giving you. So turn it 90 degrees, turn it 180, whatever they say, and then follow where that square that you shaded in goes, and just color in the correct squares as you go along. So go ahead and take a couple minutes to do that. Okay, for number 10, we should have shaded in these 3 squares. That way every time you turn it 90 degrees, that red square just kind of is going to be popping around there. For number 11, we should have shaded down here on the bottom left corner. And for number 12, you needed to shade in all the other corners that weren't colored in already.